Good morning, everyone. Welcome to Manufacturing Day 2020 in the Rio Grande Valley. We're excited to be joined with some amazing panelists today. Trung Nguyen from Royal Technologies and Dr. Esmeralda Adami from South Texas College. If you have any questions, please post the questions in the chat and we will be glad to answer your questions. But for now, we are going to head over to Royal Technologies in a couple minutes for our live virtual tour.
We're here at Mission, Texas at Royal Technologies, and we are here with the 48 best teams from Laredo to Brownsville. And this year we're sponsored by Star Wars Force for Change Initiative. It's the best of the best in robots.
We put in so many hours into our work. We have build days, practicing, testing. When we get here, it's just full on, almost no breaks until we're done. It really just takes a lot of dedication.
People of different clubs or like different interests, we can all just get together and relate to robotics. So that's something really amazing.
Where we play a part here is just giving back to the community. You know, we want to connect. We want to connect with the community. We want to connect with the kids here who are interested in STEM. And that's really our role here with First RGV.
This kind of program makes it cool to be a nerd, and it gives them a safe place to have fun, wear goofy costumes, cheer on their friends, and celebrate science, technology, engineering, and math.
Okay, we are just minutes away of heading over to Royal Technologies with Mr. Trung Nguyen. He's the plant manager and an all-around amazing STEM advocate for the Rio Grande Valley. If you have any questions, please make sure that you ask those questions in the chat and the panelists will answer your questions. We are also live on YouTube, and for those that are joining us through YouTube, we appreciate you. That makes this a global event, and we're very proud. You know, we were handed such a negative this year with COVID-19, and I always think that when you're handed something negative, you turn it around and make it a positive. So one of the things that has been a positive this time around is that while we're coming together all remotely through the use of technology instead of being in person for a tour of Royal Technologies, this is allowing our students and our coaches and our amazing teachers here at the Rio Grande Valley to share this excitement of coming together virtually with the world. So with that, let's head over to Royal Technologies with our VISTA, which is our Volunteer in Service to America, Andre Adami and Mr. Nguyen for the tour of Royal Technologies in Mission, Texas.
Hi there, welcome to 2020 Manufacturing Day with a virtual tour of Royal Technologies with First RGV, going live on Facebook, Twitter, YouTube, and Twitch. How's everyone doing today, guys? Again, just like anything else, we're doing things a little bit different. Really wish everyone could be here with us live, but in person, but we're just gonna do this a virtual tour with you guys today. So why don't you come with me and join me as we walk inside Royal Technologies. All right, guys, so we're going to walk inside the plant right now. Hey, Andre, thanks, bud. Come on inside. Melinda, our receptionist. Good day, Melinda. All right, guys, just like everything else, got to be safe. Protect yourself with COVID. Hello, Victor. Alright, guys. Well, for those of you who don't know, Royal Technologies in Mission, we are a plastic injection molding company. We do plastic components and we also have some assembly. So we're going to walk through the facility today. Our facility is 350,000 square feet, close to the size of a Walmart. So our facility is broken up into what we call bays. And this first bay that you see here is where we had the regional championship for first RGV for the last 2 years. And we're hoping to try to get you guys back in here for this coming year too. So Royal Technologies, this facility has been it was built in 2014. We've been around now for 6 years in Mission. So it looks fairly new. Cleaning up the floor today for you guys for the tour, making sure everything looks clean. So one thing that we want people to know from a manufacturing site is that safety and cleanliness is very important. So the environment that we have for our employees is important. We want to make sure that they feel safe and secure when they're working. One of our bays, we have 5 injection molding bays. This is bay 300, but I'm going to walk you guys over to bay 400. What I want to show you guys in bay 400 is what we've done to kind of reduce labor and leverage some of the technology when it comes to robotics. So currently in our facility we have about 60 injection molding presses. We employ 140 employees. The work that we do is not very labor intensive, but it does require skilled labor. So to kind of give everyone a perspective, what I always try to explain is back in the 80s, plastic injection molding, every single press had an operator running the injection molding press. What those operators used to do was they used to remove the parts from the press. Fast forward to today, we have robots on each of our presses. So those robots then remove the parts from the press. And so really what we have now with our operators is they're packing parts and doing some inspection, but very minimal. We leverage our technology, we leverage our controllers on the press to control the quality of the parts. So as you can see right now, we have 12 presses in the bay, and we only have 1 or 2 operators running the bay. We do have a supervisor who is a technician who operates the equipment, and then also with another mold tester. As you can see here on this press, we have already the packaging on the conveyor belt. What's happening is that when we get to the parts, all the parts are getting packed right into the box. Anything over here too. Right into the box. Again, very minimum labor. So, also another thing I always kind of want to explain to people propylene. Very soft material. So what you see here is the resin is poured into the hopper and then it's dropped into the injection side of the press. The injection side of the press, there are heaters inside. And so what happens is the barrel temps are set anywhere between 300 to 500 degrees, depending on the melt temperature of the plastic. You don't melt it the whole way, and so what happens is there's a screw inside, and that screw, using friction, does the final melt of the plastic. So it's almost a pre-melt, and then using friction, melts the plastic forward. It goes from solid to liquid, and then back to solid. So then plastic goes into the mold. Comes out there, and this steel has the shape of, it's the reverse negative of the part that we want to be molded. So the steel is cooled, it has water lines running through it, then cools the plastic before it comes out. Then you'll see it. Everything, the process is controlled on the front end, and then with the auditors will come and do some visual checks and some quality checks depending on what the parts that we're running. Also, inside here, so for every single plastic part that we make, there is a tool. And so every part has specific tools to be made. And so what you can see here is these tools will drop inside the injection molding press. Where I was speaking to you earlier, this is the injection point. This is where the plastic shoots into the mold, and then our molds open up. People always ask, why do we call them, for example, the one press that we saw was a 200-ton press. People always ask, well, what's the tonnage for? That tonnage is the clamp tonnage, okay? And so what happens is, as the plastic is shooting into the injection point, there's a force that pushes the mold open, okay? So that's the physics behind it, was why you need clamp tonnage to keep the mold from opening up. Another thing here is you'll see a lot of different colorants. And so what you saw there was a natural plastic, it's natural. And so depending on the color of the plastic part, we'll add a colorant, whether it's black, tan, gray, whatever color that the customer wants. Also, some of the products are automotive components and also chair components. So in that bay, in Bay 400, you'll see a lot of small seat belt covers, seat covers, and also in here you'll also see some seat covers. Some of those parts that we produce, they ship up to Toyota, the Toyota plant right outside of San Antonio, Avenstar. So we went from small tonnage to large tonnage to larger press or larger molds. The molds get bigger, the injection points are about similar to the same size. So it's a linear process. Again, as the parts get bigger, the molds get bigger, and the presses get bigger. This first press that you see here is a 500-ton press. It takes 500 tons to keep this mold from opening up. Tools can weigh anywhere from 3,000 or 3,000, yes, I'm sorry, 3,000 to 5,000 pounds. We'll need a large gantry. We've got a 10-ton gantry over there that will lift these tools and set them inside the press. Walk over here, Mark. This one's nylon. It has glass fibers in it. Normally I like people to touch it because the other plastic is much softer. This one is a little bit more coarse, more hard, dense. And so what you see here is some plastic will need some structure. So this bolster used to be metal that was converted to plastic. So when you convert metal to plastic, you need a strong material such as glass-filled nylon. And so with this glass-filled nylon, we actually have to dry it because nylon is hygroscopic. It will absorb water, it'll absorb moisture from the air. And so what we need to do is we need to dry the material and remove that moisture from the plastic so it doesn't cause any cosmetic defects, which we call splay. Okay, our supervisor setting up the press. Again, for us, it's very important, this type of skilled labor. Jorge has been with us for, actually he's been with us since the beginning. He had plastic injection molding experience. He was actually a maintenance technician who came on over to become a supervisor. And so for us to have supervisors in our plant, it's important because not only are they supervising people and they have to have the people skills to manage our operators, they also have to have the technical skills. So what you're seeing here is he's setting up the process. He's also setting up the robots. He has to understand not only a little bit of chemistry, but a little bit of programming. And here's his setup that he has. Again, that skill set for us in the Valley, I think, is very important. Some of the other parts that you see here are parts that we make for steel case. We ship them over to Reynosa. Steel cases are probably one of our primary customers here in Michigan. They're pulling out a tool right now. So we just wrapped up running this product, and now we're going to remove this tool and get ready for the next changeover. In this press, we run the top cap for the batteries for the wall tools, power tools. So these parts get shipped over to our customer who is just right down the street in Mission. So hopefully one of these days I can also try to connect you guys over to that plant, because I think that would be a cool plant for to see. So Pablo, if you're watching live right now, hopefully you'll raise your hand and do a plant tour for the first student. So those trains that you guys see there, So another thing that we've been trying to do is prepare ourselves for material movement automation. Right now, what you do see is you do see a forklift driver pulling that train. We're hoping in the future that we can get a sort of automated tugger to move material around into the plant. If you look back behind you here, this is our warehouse of finished goods. We have about a week's worth of inventory in our site. And so if we shut down for about a week, this warehouse would be empty. So I always think that's impressive to show people. Go back in the tool room. Hopefully they'll have a tool that's split open so you guys can see what the inside of the injection mold looks like. Well, we do have a tool here. I guess because they knew that we were going to go live and do a plant tour, they really tidied up, which is good. I'm very happy with it. But back here, what we want to show you guys is, again, for us, preventative maintenance is important. We want to take care of our customers' tools, and we also want to take care of our presses. People always ask who owns the tools when we make these parts. Our customers, they own these tools. And so we want to make sure that we're good stewards and we're being responsible. And I think the key thing in terms of making a good quality part is always making sure that the tool is in good condition. And so just like your car, you got to take it in for a tune-up. We'll also take the tools, we'll tear them apart, clean up the tools on the inside, because sometimes you'll have some resin buildup, gas buildup, and then also sometimes you just got to lubricate some of the moving parts. So for me, please bear with me. First time doing a virtual tour. I'm used to having people with me asking questions. So as I'm walking around speaking to you guys, things are just popping up in my head. Now we're going to walk into our assembly area. So again, as I mentioned to you guys, 350,000 square feet. Right now, we are at 60% capacity with room to grow. Here you'll see some kit boxes, the walk kit boxes. They get shipped to our mission plant, they get shipped to Reynosa, and they also get shipped to Fort Mill, South Carolina. So to my left here, what you'll see is just our shipping area. In our shipping area, we have 10 dock doors, and every single day we average anywhere from 10 to 15 truckloads going out our door. Maybe 6 to 8 crossover into Reynosa into Mexico. But what you see here is the guys have all their orders lined up, getting ready to pack up our trucks. The one thing that we also, not only do we pride ourselves on quality, we also pride ourselves on delivery, making sure that we never miss a shipment to our customer. Year to date, knock on wood, we're still at 100% on-time delivery. walking into our assembly area. So when we first opened up over 30 years ago, the name of our company was Royal Plastics. And then what you'll see is the core of our work still is plastic injection molding. But we made a strategic decision that we wanted to do more for our customers. And we wanted to figure out ways how we can be, or we can add more value to them. And so we turned our name from Royal Plastics to Royal Technologies, so that we can do a little bit more besides injection molding and do some what we call light assembly. So what you see here is a subwoofer box that comes in two pieces. The subwoofer box now is going to be what we call hot plate welding. And so there is a plate on the inside of this press that will melt the rim of the plastic. And we'll use the plastic to seal itself. So once it's sealed, we'll do a vacuum test to make sure that there's no air leaks. So in the assembly area, we have vibration welding, ultrasonic welding, hot plate welding. And because of COVID, what you'll see here, guys, is, again, we had to take measures to make sure our employees are safe, putting in plexiglass, making sure that everyone is distanced out. Before, this used to be a 5-person station, and because of COVID, we've converted to a 3-person station. Again, separate our assemblers, and then also protect them from each other. Alright, guys. Well, that's pretty much our plant in a nutshell. Nickel core. Again, this is where championships were held for the last 2 years. Hopefully we can get you guys back in here again, all depending on what's going to happen with COVID. All right, guys, well, thank you very much for joining us for our first virtual tour. Hope you guys enjoyed it. Don't forget to post any questions that you may have inside the chat, and we'll answer them as best as we can. So thanks again, and have a wonderful manufacturing day.
All right, we are switching over to get our panelists started. Please make sure that you post your questions online. We'd love to hear your questions. We do have a couple questions already in the chat. So for the panel, what is the manufacturing process?
can hear me?
Yeah, I can hear you, Trung. Can y'all hear me? Okay, Dr. Adami?
Can you hear me?
I can hear you, Mr. Nguyen. It sounds like you're pretty digital, though.
Hi, everyone. Good morning. Thank you for joining. Thank you,
Dr.
Trung.
Adami.
Yes, it was a wonderful tour. Thank you. I do see, I don't know if Trung's having issues with his mic, but I can answer as much as possible. I know I did answer some on the chat. Let's try to see if Trung can answer. If not, I can jump in for him. Did he freeze?
You may have froze. Trung, if you want to go ahead and reconnect, we'll start with Dr. Adami. Dr. Adami, what certificate programs are there available at South Texas College for robotics?
Okay, I know robotics offers a certificate, again, in mechatronics. That's what it's called. That's where we teach the actual robotics. A lot of electrical, a lot of design, a lot of actually, dealing with the robots. What we offer are certificates. Also, we're currently working on offering some NIMS credentials under robotics. Again, when these will be under the mechatronics degree, which goes hand in hand with manufacturing as well. We'll see if Trung works before I move on.
Okay. Mr. Nguyen, can you hear us?
I think he's having issues.
Choppy? No? Yes?
No, we can hear you now. Your audio sounds good.
All right.
All right, Mr. Nguyen, we've got a couple questions for you.
Okay. Good. Where do you guys want me to start?
How about this? What are examples of plastic parts Royal Technologies make?
Okay, examples of plastic parts. In this facility, we make parts for office chairs. So the chair that I'm sitting on right now, all the plastic on the chair, we make it here in this facility. And then we also do automotive interior. So the mat pockets that you see on the side door panel, the cup holders inside in the middle of your car, the door panels, those are examples of plastic parts that we make here.
Okay, and another one for Trung. What would be your answer to the question about describing the manufacturing process?
Okay, again, the manufacturing process for us here at Royal, we call it plastic injection molding. So again, I apologize, guys. I know that when you're on the plant floor, it's very hard to hear. But yes, our process here is plastic injection molding. We melt the plastic and we mold it into the mold. That's our primary process. And then our secondary process is assembly. So we do assemble those components.
Violetta asked a question. I believe you just answered it, but I just want to make sure. Do you guys only do plastic injection molding there?
Again, primarily just plastic injection molding, but that's partly the reason why we switched from Royal Plastics to Royal Technologies. And so we do secondary operations, hot plate welding, ultrasonic welding, vibration welding, and assembly.
Okay, great. Thank you for that. Looks like Xavier Gonzalez has a question. How many engineers does your company have, and what kind are they?
So in our facility, we only have 2 process engineers. Those process engineers studied plastics, chemistry. Corporately, we have design engineers, we have manufacturing engineers. So we are a company of 1,000 employees, and I want to say that of the 1,000 employees, we have 50 engineers. 50 engineers.
That's great. And Dr. Adami, here's a question for you coming from YouTube. Are you from the Rio Grande Valley?
I am. I actually, as well as Mr. Trung, we're both mechanical engineers. I did go to the, back then used to be called the University of Pan American, and again, major in mechanical engineering.
That's awesome. Trung, let's see, it says, how long, another question from YouTube. How long does it take to make a tool that presses parts?
Okay. For our tools, it can take anywhere from 4 to 8 months. So you're talking about either the design portion of it or the manufacturing portion of it or the machining of the tool. And then sometimes after the machining, you got to sample it, process it, make sure it's okay, and then remachine it. So I would say it's about, on average, you can probably build a tool in 6 months.
Okay, great. Great answer. We got a question from Juan Rivera. What is vibration welding?
Vibration welding is exactly what it is, or what it says is vibration. So what happens is it uses friction and the parts vibrate together. And with that friction, it melts the plastic and seals it together.
I got to do a follow-up. This one's for me. This is from me, Trump. How reliable is vibration welding? I can't imagine that process being that reliable.
Oh, it is. It is. It's very reliable. So even with metal, you see it, right? And so with metal, they call it friction welding, right? So to me, friction welding and vibration welding for plastic is very similar. Same concept, but very reliable.
Okay, and then we have another question from Violetta that says, what part of the process is the most time consuming?
Wow. I don't think there's anything that's very time consuming anymore. The overall process, if you want to talk from beginning to end, is really producing the mold, machining the mold, and then setting up the process as you're trying to figure out how the plastic melts. But once you get all the engineering done, the actual process itself it's pretty quick. It takes about a minute to do a plastic injected part.
Yes, if I may add, usually I was thinking the same thing. Once you do the process, the actual design and what you want the end product to do, you'd work with the process engineers, you work with the designers, you work with the machinists, whoever your team is. After that, after it's done, it's quick.
Well, yeah, because Trung, you mentioned
that goes for any design.
Yeah, because Trung, you said it takes about 6 months just to make that tool, that press, right? So, I mean, that's probably the longest, right?
And maybe Dr. Esmer can talk a little bit about that, because that's what they do over STC in terms of teaching the students how to machine steel. So
yes, again, I know currently right now, myself and some other another faculty, we're actually helping a national company design or work on a product. They bought a machine that's not working to what they wanted, so we're trying to design. So we're having to go back and forth. We went to measure. We met with the owner, see what they wanted. We went back and made the sketches. That we did the 3D designs. Went back again to make sure we were correct. We went back again to did a prototype in 3D printing. We went back to the company to measure, and again, all that's taking a long while. However, once it's done, it's going to be quick.
That is really cool. That speaks a lot to just how efficient that process can be. Dr. Adami, I have a question from you coming in off the YouTube. Do you have any words of wisdom or advice for young Hispanic women interested in being an engineer?
I always say that if you want to do whatever you want to do, you can. Don't feel intimidated by being a female. Don't feel intimidated by being Hispanic. I know my whole research was done in persistence, especially for Hispanic females. And what I got to see on my research was such thing as cold rooms. That's what they call them, cold rooms, which means that they refer to this as being very little females in the room, in the classroom, where even the professors will call very little times on the females. So they felt like, okay, am I not smart or what's going on? So they refer to this as the cold rooms, meaning that a lot of times it felt like they were not good enough. So they ended up dropping. Okay. So please don't feel like this. Okay. If you put your mind into it, and this goes for men also, regardless of if your background, whether you're Hispanic or not, but you can do it. Yes, a lot of people ask me, is there a lot of math? Yes, there is. Okay. But just like you thought pre-K was hard and then you went to fifth grade and you thought it was hard, everything is being taught. So you get to learn in the process. Just keep going and don't feel like, I'm Hispanic, I'm female, I can't do it. Yes, you can. If I did it, you can do it too. My background was not, was staying. My parents didn't go to college even. So don't feel that English was not my first language. So please don't get any roadblocks, nothing to intimidate you from pursuing engineering.
Okay, well, sounds good. Thank you for that. That is some great advice. We have some more questions coming in. In fact, there's a question for me wanting to know if I'm excited about this year's Ultimate Goal Challenge. And yes, I am. And we are really excited about having our robotics kids come back together for another exciting season. So this message is for Mr. Nguyen. What type of robotics technicians do you have at Royal Technologies?
We don't have robotic technicians. The supervisors and the PEs, or the supervisors that you see on the floor, they're trained robot programming, right? And so their skill sets is not just robot programming. It's only a part. It's a function of what they're doing. And so important skill sets of programming, it's logical programming. The robots are C pros that we use here. So that's one function that they have to do. Plastic processing is the other, and then people, right? Those are probably the three main skill sets for our supervisors.
Okay, that's great. Thank you. Do you know, either one of you, I guess this is for either one of you, do you know about how many advanced manufacturing plants are in the Rio Grande Valley?
I know there's over 100, and I know a lot of them, I think, and I want to say maybe in close to 200. Again, we're talking about Bronzeville all the way to us. But I think that's the right number, Trung, correct?
That is correct.
And then during COVID, you would think that a lot of the companies closed. A lot of them didn't. A lot of them actually went on and actually hired. I know because I helped place over 19 out of just one company during the summer. So again, a lot of these companies, I mean, you talk about Procter & Gamble. I mean, they were going nonstop, doing that essential products that everybody was fighting for. So again, it's really interesting, really interesting.
That's really cool. Thank you for that. What are some things that can be made with injection molding technology? I think this is for either one of you.
You want to field it, Esmer?
Well, it's just, again, what we saw here, that trunk, thank you for the tour. That's just some. I know I don't know if he talked about every single product, but besides chairs, here in Mission, Texas, they manufacture stuff for Black & Decker. Okay, they manufacture a lot of cases for, I believe, lawnmowers. And they manufacture a lot of stuff for casings for different drills. And again, besides that, there is your milk jugs. That's also plastic injection. Anything that has plastic, and you see the little, I guess, what is that called, Trung, at the very bottom where the injection goes in? Yep. The little dots, a little circle. you know, anything like that, you're talking about plastic injection.
That is correct.
All right. Let's see. We have a question from Xavier again. On an average week, about how many parts are you all creating and shipping out there at Royal Technologies?
On an average week, a lot. We make a lot of parts. I used to be able to give you a count on the pieces that we make. It's gotten so large that I just talk about dollars now. So we ship about $1 million a week worth of product.
Well, we appreciate your contribution to the economy. That's some good money there, Trump. Let's see. A question from Angela. Do you guys only make plastic, or do you also turn it into objects like for office chairs? And I think that was covered during your tour, but I think that was a little hard to understand.
Yeah, so the parts that we make, we only do the sub-assemblies. All the parts that we do make, again, we ship it over to Reynosa, and Steelcase is the furniture manufacturer. They're the ones that put all the pieces together. They put the steel, the wheels, the fabric, they assemble all of that, and then ship it back into the US.
All right, sounds good. It looks like we have taken all the questions. Last call for questions. Is there anything you would like to add at this point, Dr. Adame?
If I can go back to just emphasize on how fun manufacturing is, and it is actually, it ranges. Again, right now you only saw a little bit of manufacturing, which is plastic, but if we go back to all those companies that are in the Valley, we're talking about metal stamping, we're talking about a lot of quality, we're talking about measurements, we're talking about you know, a lot of, you know, variety of different things. I mean, now we have SpaceX here, they hire, and again, they were talking about what type of degrees. They hire certificate, associate level engineers, and the actual job that you can do with this robotics, mechatronics, it's amazing. You know, you might think you like robotics, and then you end up working and you really fall in love with the CNC. Or you might go into, you know, working, for example, Trung. I mean, he has a lot of different people working in the plastic, people working on the machine portion of it, doing a little bit of welding. People are doing the whole processes, the process engineers work with computers, you work with tools. It's just, it's amazing. And not just that, but it pays very well. Okay, a lot of people think that manufacturing does not pay well. It does. And again, besides that being fun, and if I can add, the last thing is make sure that you do something that you love. You want to make sure that you work and where you like your job, where you're eager to go to work, where you learn something new every day. And it's just, again, it's fun.
Sounds good. Those are some great words of wisdom, Dr. Adame, and thank you. Mr. Nguyen, any final comments or recommendations for our great attendees today?
Yes, definitely. Again, I just want to, you know, tag on with what Dr. Esmer said in terms of how fun and enjoyable manufacturing is. But you got to do it because you love it, right? And you have to have passion to do it. And I think that applies to anything in life. But the main thing here is with Manufacturing Day, we want to create awareness, right? We want to let folks know what is manufacturing. And so again, anything that you have in your home has been manufactured somewhere. So manufacturing is just taking raw materials, whether it is furniture, whether it's your computer, whether it's your TV, it's everything in your home has been manufactured. Now, the question here is, where are these things being manufactured? A lot of it historically in the last 20, 30 years has been manufactured in China, okay? China has done a great job with their infrastructure, setting things up for manufacturing. But the reason why everything used to go to China was because it was more cost effective. Things are changing now. And I think that in order for the United States to get better and to improve and to help the economy, we have to get back into manufacturing, okay? And I think it's very important that you have folks who are going to universities and college to get a degree. But I also think that it's very important that some students who are not fit or don't feel like they want to go to college or universities to go get a skill, to get certified, because skilled trades are also important, right? And so I think that's where we have lost it in the last 20 years, is we focus so much on engineering degree. I'm an engineer, you know, I'm not knocking it at all. But what I can tell you is the one biggest gap in manufacturing today is skilled labor. And when I say skilled labor, it's the folks who want to work with their hands and mind at the same time, right? Skilled labor is also the computer programming. Skilled labor is the guys who are setting, and then also machining. All of that is skilled labor. So and over at STC, they do a great job of teaching those skills and to prepare the region for the future.
Sounds good. I appreciate
That's all I
that.
got, Jason.
Dr. Adame, did you have a follow-up to that, or are you done?
Sure. We do offer at South Texas College different degrees. Again, going back to the skills that Trung was talking about, that, and I want to add to everything he said, was the soft skills. Make sure you work, you know how to work in teams, you know how to communicate, you know how to be communicative, you know how to write memos, even, you know, writing skills, and your speaking skills, the network that you build now is going to help you in the future. But sure, South Texas College, we have amazing degrees there. You are more than welcome. Later, we can plan a tour, virtual tour probably for now. But yeah, so you know, we offer robotics, mechatronics, and then machining, your CNCs and machining, all those courses. And again, going back to, again, just resonate what he said, again, all those skills are very important. And it doesn't say that, you know what, I want to be an engineer. If you have these skills and then get later a degree in engineering, you're worth a lot more.
Very good. Well, that has wrapped up our time for today. I do want to thank our amazing partners over at South Texas College and Royal Technologies, both Dr. Adame and Mr. Nguyen. Thank you for your time today. For all the students, a special shout out to our friends down in Brownsville. Thank you all for joining us today with Brownsville ISD and also Mission CISD. Thank you guys. We love you. And for those that have no idea what First RGV is, please take time to visit our website, firstrgv.org. You'll learn quite a bit about our amazing educational programs, specifically our robotics programs. And we are planning to have a season this year, and we will see you soon. Thanks again, everybody. And finally, our sponsors, Texas Workforce Commission. Thank you, Commissioner Julian Alvarez, for being such an amazing supporter. We'll see you soon.